So for number 41, I'm given this series here, and I want to find out whether the series is convergent or divergent. So what we're going to do here is we are going to split this up into two different series. So that's going to be from n is equal to 1 to infinity. And the first part is just going to be this 1 over e. But what I'm going to do here is write 1 over e to the power of n, because I'm just attaching the n to 1, but 1 to the power of n is just 1, so that doesn't change anything. And then plus the sum from 1 to infinity of 1 over n times n plus 1. So what we're going to do here is the second one, we're going to break it apart using partial fraction decomposition. So 1 over n times n plus 1. I want to decompose this into some coefficient a divided by n plus b divided by n plus 1. So for us to find what a and b are, what we're going to do here is we're going to put a and b into a single fraction. So if we were to join this, they would be all over the common denominator, which is n times n plus 1. And then we will multiply a by n plus 1, so a times n plus 1. And then we would multiply b by n, so plus b by n. So once we're here, we can see that the denominator is already equal, right? So n times n plus 1 is equal to n times n plus 1, so we can just go ahead and ignore that. And we're just going to focus on the numerator. So 1 has to be equal to a times n plus 1 plus b times n. So because this equation here has to be true for all values of n, what we can do is choose strategic values of n that would make solving it easier. So let's consider the case where n is equal to 0. So if n is equal to 0, we have that 1 is equal to a times 0 plus 1 is just 1, plus b times n, which is 0, so that disappears, and therefore it means that a is equal to 1. So we have here that a is equal to 1. And so once we found that, now let's consider the case where n is equal to minus 1. So 1 would be equal to a times minus 1 plus 1, so that would be 0, plus b times minus 1. So once we have this, we have that 1 is equal to minus b, and the conclusion, therefore, is that b is going to be equal to minus 1. So once we found these two coefficients, we now plug them in here, and we can rewrite this as a over n. So a is 1, so that's going to be 1 over n, and b is minus 1. So minus 1 over n plus 1. And so we're going to rewrite our series as that. So let me rewrite this as, 1 over n, and then minus 1 over n plus 1. Okay, so once we have rewritten this, let's expand this and just see where this goes to, right? So we're going to begin plugging in n is equal to 1. So if n is equal to 1, we're going to go 1 over 1 minus 1 over n plus 1, so 1 over 2. And then plus, now let's consider the case where n is equal to 2. So that would be plus 1 over 2. And then minus 1 over n plus 1, so minus 1 over 3. And now when n is equal to 3, we have plus 1 over 3, so plus 1 over 3, and then minus 1 over 3 plus 1, minus 1 over 4, and so on and so forth. So we can see that this sum here, this is the situation where n is equal to 3. We got these 6 terms. And we can see that what's always going to happen is that they're going to cancel out in pairs. Like these guys cancel out, these guys cancel out. So no matter how many terms you add, you're only going to be left with the first one, which is 1 over 1, minus the last one. So we can say that since these cancel out, what we can do here, let me rewrite this. We can say that the sum as n is equal to 1 to infinity from 1 over n minus 1 over n plus 1, this is actually just going to be 1 over the first term, so 1 over 1, that's not going to change, so that's just going to be 1, minus the last term, which is going to be minus 1 over n plus 1, right? So that is what it's going to be. Like if we made this, for example, if we consider the case where n is equal to 4, where we would add this, maybe we would add plus 1 over 4, and then minus 1 over 4 plus 1, so minus 1 over 5. So we can see that no matter how many iterations of n that we choose, we're always going to be left with this first one and the last one for whatever value of n. This first one is always going to be 1, it doesn't change, but that last one is going to be dependent on n. If I chose n is equal to 4, that last one is going to be minus 1 over 5. If I chose n is equal to 5, that last one would be minus 1 over 6, and so on and so forth. So once we have this, we can now rewrite this as the sum from n is equal to 1 to infinity of 1 over e to the power of n plus 1 minus 1 over n plus 1. And this whole thing, we're taking the limit as n goes to infinity. Because this thing here, it describes our entire sum, right? If we want to sum up the first 10 terms, it would just be 1 minus 1 over 10 plus 1, which would be 11. If we want the first 100 terms, it would just be 1 minus 1 divided by 101. So this thing here, it describes our sum, and we just have to plug in a value of n. And now we want to take this limit as n goes to infinity because we're summing up infinite terms, right? So if we take this limit as n approaches infinity, what we're going to have here is we're going to have the sum as n is equal to 1 to infinity of 1 over e to the power of n plus the limit as n goes to infinity. It's just 1 minus 1 divided by infinity is 0, so just plus 1. So we have simplified this whole thing into this series. And now what's left for us to do is to decide, okay, we've seen that the second series, it converges to 1, but what about the first series? What kind of a series is it? So let me erase all this stuff so that we can focus on that first one. So that first one is the sum as from n is equal to 1 to infinity of 1 over e to the power of n. And this is a geometric series because we have some ratio raised to n. So we have a geometric series where the ratio is going to be 1 over e. And 1 over e is less than 1, so we can say that the series over here converges. So all we have to do here is use the formula for a series, right? We have to use the formula here. So this formula is going to be, that's going to be a sub 1 over 1 minus r, where on top we put the first term, whatever we get when plugging in n is equal to 1, and on the bottom is just 1 minus the ratio. So if we plug in n is equal to 1, our a sub 1 is just going to be 1 over e to the power of 1, so it's just 1 over e. And our ratio, the thing that's being raised, our ratio is also 1 over e. So this sum over here is going to be 1 over e divided by 1 minus 1 over e. So we are nearly done. So once we've found this, because this is a geometric series, we can now rewrite this as 1 over e over 1 minus 1 over e plus 1. And this over here is our final answer for 41. So it does converge. It converges because the first series is a geometric series with a ratio less than 1, and the second series is what is called a telescoping series, where all the terms cancel out except the first one, which is going to be 1 over 1, minus the last one, which is going to be minus 1 over n plus 1. And that is it for problem 41.